part C asks for us to evaluate the integral of x plus 3 over x squared minus 5x plus 6 dx. And so we don't have this integral isn't in a form that we have any antiderivative rules to solve directly. And we can't use substitution, wouldn't really help because of this ugly denominator. And but this integrand is in a fraction form, which x squared minus 5x plus 6 can be rewritten as with factors. So the best way to solve this integral was through partial fraction decomposition. So the first thing we had to do was rewrite x plus 3 over x squared minus 5x plus 6 as the sum of two fractions with denominators of the factors x minus 3 and x minus 2. And so we need to solve for a and b. And to do that, we set x plus 3 over x minus 3 times x minus 2, this original fraction, equal to these two fractions, but we just rewrite them using common denominators. And so once both sides of the equation all have common denominators, which is x minus 3 times x minus 2, we can just ignore those and say that x plus 3 equals a times x minus 2 plus b times x minus 3. And then we can, to solve for a and b, we can isolate each variable by making the factor the other variable is multiplied by equal to 0. And so to solve for b, I set x equal to 2. And so we plug 2 in for x here to get 2 plus 3 equals a times 2 minus 2, which is 0. And then plus b times 2 minus 3, which is negative 1b. So 5 equals negative b, so therefore b equals negative 5. And then to solve for b, to solve for a, we isolated it by making x equal to 3. So this term here will cancel out to 0. So then we are left with 3 plus 3 equals a times 3 for x minus 2. And then simplified, 6 equals a. So then we can rewrite this original fraction as 6 over x minus 3 minus 5 over x minus 2. And so we can rewrite this integral given as integral from integral of 6 over x minus 3 minus 5 over x minus 2 dx, which can be rewritten as 6 times integral of 1 over x minus 3 dx minus 5 over 1 divided by x minus 2 dx. And so using the natural log antiderivative rule, we can take the antiderivative of both of these integrals to get this line. And then we also have to add a c at the end because both of these integrals, their integrands could have antiderivatives with a c value. That was canceled out when the derivative was taken. And so we can rewrite 6 ln of x minus 3 minus 5 ln of x minus 2 as ln of x minus 3 to the 6th minus ln of x minus 2 to the 5th with logarithm rules, and then plus c. And so then it simplifies to natural log of absolute value of x minus 3 to the 6th over absolute value of x minus 2 to the 5th plus c.